Welcome in, folks. We're going to continue on object-oriented programming. We're going to do these first two topics today. Last week we introduced object-oriented programming, but folks might not have gotten the bigger picture yet. So we'll do this again, but with a different example. Right? And then towards the end of class, we're going to put objects into a data structure. More specifically, we'll probably stick with like an array list, because those are typically a little stronger. So yeah, just these two things today. Just to recap things a bit, last week we spent quite a bit of time designing this counter class. This is a like a cookie cutter, and we represented it as a class that has one private member, a member variable, and then there's some public interfaces that are like buttons, which allow the user to change this value safely. So yeah, well, we ended doing this last week. I'm right over here. If you, this was really just a fancy integer, by the way. So I don't think people got the bigger picture here, because it really just looks like we made an integer look super complicated. So we're gonna do this example here, which might help you visualize object-oriented programming a bit more. This is some people might have played like an RPG game. This is a role-playing game, and some of these role-playing games consist of bars. Like they have health, they got mana, they got stamina or energy. So you can think of these as like member variables that belong to player. If we were to design such a class, we would be able to design like an RPG game, because RPG games or RPGs, they rely on players kind of interacting with each other. So by designing this cookie cutter, we're going to be able to create multiple players that can interact with each other. All right, so let's do this example today. Okay, and then just kind of giving a sneak peek into the future. On Thursday, we're going to cover something called inheritance. Inheritance is a fancier objects. That's what you can think of it as. And then next week we're gonna build upon that. I feel like people might be getting tired of the terminal now. Like, you know how we've been doing most of our work and seeing the output in like a terminal. I think we're gonna move on to a library that will help you do some graphics. There's a library called JavaFX. We'll do this next week. But yeah, JavaFX, this is a Java library. It consists of classes, and you can use those classes to create objects that will make it easier for you to design like a graphical user interfaces. So this will make things a lot easier. Let me check these out real quick. Detailed reference. I'm trying to find some examples here. What is JavaFX? Getting started. Yeah. So next week we're gonna use this library called JavaFX, and these are some really small examples. Like here, if you were to here, let me check this one out here. So this is a Java program right here. Let me scroll down to the bottom. The Java program. It's got a button, and then it's got a window here too. And this, to create this, it relies on understanding object-oriented programming. And also inheritance, which we'll cover on Thursday. So you could look at some examples here. The example here, they're pretty much designing a class, and this extends application means that there's some inheritance going on. It means that this class relies on another class. Right? So it's inheriting methods from another class called application. Okay, and by inheriting functionality from this, you're able to kind of reuse stuff and make certain things custom. So towards the end, you're pretty much reusing other people's code to make graphical stuff. And there's tons of small examples here, but you can carry on with making cool stuff. Like you can make Pong too. you could make a Snake, like those small two-dimensional games. Anyways, we'll give a sneak peek on this later. That's kind of the bigger picture here. But anyways, for today, let's spend the majority of time designing this player class, a cookie cutter. All right. Okay, let me pull up my VS Code here. I'm just gonna quit all of this. Quit. Okay. So for this example, we're gonna be designing a player class, and you'll see that this class can help you design like a skeleton for a RPG. So it might be useful to have two separate files for this. Like you could have one file that represents the class, and then another file that represents the logic for the game. All right, so I'm gonna go ahead and create a directory for this, just to keep things organized. Let me create a folder here. I'm gonna call it RPG project. RPG project. Yeah, I'll call it RPG project. RPG project. Let me put an underscore in here so you can read it. Okay, cool. There it is. And then let me make two files in here. I'll make one called like a game.java and then another one called player.java. Okay, so I have two files in here. I'm planning on putting the class in player and then the main logic in the game right here, like having the main live here. Okay, let me just cd into it real quick. Cd into examples, cd into RPG project, and then I should be able to see it. Cool, I see both files now. Okay, let me see. Okay, we should probably start off with the main first. I'm gonna start with a bottom-up approach, kind of like designing the main, and then as we need more functionality, we'll start implementing the player class like one by one. Okay, so for the main, let's go ahead and put the entry point in here. Okay, so there's the main, and then let me go ahead and save it. Okay, here's what I mean by bottom up and designing stuff in the player. Imagine we enter the program and say we want to spawn some players. Right, so spawning players means to construct. All right, so we saw this last week. You might want to review that stuff if you're not sure what constructor means. Yeah, constructor. Constructor is a way of initializing a method. So say we were to spawn a player by constructing them. All right, we could say something like player P1. All right, people see what I'm trying to do here. I'm trying to say declare a object named player P1, and maybe I'll set it equal to a new player. All right, so what is this line trying to do? This line is trying to construct a object and initialize some member values. That's what it's trying to do. Let me just comment that out real quick. So this is constructing a default player. And the reason why I say default is because we're not giving it any information. Like this is a default constructor because we're not putting anything inside of it. All right, you might remember from last week we talked about default constructors and overloaded constructors. We'll talk about both again today. Okay, so this is trying to construct a default player. Unfortunately, if we were to compile it right now, it's not gonna work. So let me go ahead and try compiling it. Java game.java. And it doesn't compile. The first error message, it says player doesn't exist, and it's saying something about the bad source file in the player.java. So yeah, it's pretty much saying that this cookie cutter does not exist. So let's go ahead and make it exist. The bare minimal syntax we need to make it exist is by creating a public class in this file here. So this is, I'm gonna create a public class. Right? The reason why it needs to be public is so other people can access it. So public class, and then I'll call it player. And then very important, you do need these curly braces here, this defines the it defines the what the cookie cutter looks like. All right, and typically these are on multiple lines. And I know it looks like a method, but it's not. This is actually a class declaration. So this is a class declaration where we're making a cookie cutter exist. All right, so this should be enough to compile now. Let me go ahead and Java this. And cool, it compiles. It doesn't do anything yet, but maybe we could start implementing some functionality. Like, let's see. So it looks like here, if we wanted to represent a simple player, they have some member variables. Like they have a name, like a string. This is a string, and then maybe some numbers, like a health number and then a mana number. So we could represent those as member variables. And if you might remember, member variables are more suitable to be private. So, so how do you declare a private variable again? Let me look at the old example over here in the counter. Let me see, counter. Yeah, so you just put private and then the variable here. Okay. Cool. So if we wanted to do this name here, this is like a string. So you could go like a private string name, and another one. So two numbers, right? One for the health and one for the mana. So private int health, private int mana. Okay. So these are member variables. Okay, and the reason why they're private is to prevent unauthorized access. You could make these public, but then it could let users do bad things with their class. For as you might recall from last week, you could access member variables and kind of write them, right? If this was public, you could do something like this right here. Like you could say p1.health is equal to like a negative 200, 2000 or something. Right, so this is just a random thing. I'm saying set the health variable equal to negative 2000. Since this is private, is not even going to compile, which is a good thing, by the way. It doesn't compile because it says health is private. So the reason why this is good is because we're preventing inappropriate use of the player. Right? And by inappropriate, it should be impossible for health to be negative. It just depends on how you're thinking. But in my opinion, this should be impossible. But if health were to be public, I see if health were to be public, then it's going to be possible. It does compile, and you can output. You can access it like system.out.print. You can read access and print something like the health. P1 health is, and then let me put it in here. I don't recommend typing this because I'm going to delete it, by the way. I just want to show folks the difference between public and private. And then let's see, and then P1 health. So this does run, but it's inappropriate use of the member variables. So it's more appropriate to make this private because we want to design methods that will allow the user to do this a little safer. All right, so let me go ahead and compile this again, and we should see an error message, a good error message, private. Okay, so let me remove these two things here because they're can't do those. Okay, so what are we doing here? This is constructing a default player. It's like a default player where we give no information. So it might be useful to declare a constructor for this. If you might remember, a constructor looks like this right here. So this is this is invoking a constructor, but in order to make our own, we could make it as a function here, a method actually, because a constructor is a method, right? And the name of the method is the same name as the class itself. So if we designed a constructor for this, first of all, it will be public. Right? It needs to be public, otherwise the main would have no access to it. All right, and then the name of the function, name of the method is player. So player, and then don't forget these parentheses here. This says that it's going to be a method. Okay, so this is right here. This is called a default constructor. All right, let me put a print statement in here so you can visualize what's happening. Say constructing default player. Okay, now if I go ahead and compile it, Java game, and then compiles, and then it is running, and yeah, so it's constructing default player. Okay, cool. So we constructed a default player, but it's got no information. Typically, you'd want to display. You'd want to initialize these variables here. This is like saying when we construct a player. Right, so this is invoking the default constructor, by the way. So this is invoking the default constructor. It's saying when we spawn a player, it's being spawned right here, and maybe we should initialize these variables here. All right, so you can initialize these variables however you want, but I'm gonna hard code them to some names here. Like I'm gonna say this name is equal to something. All right, this refers to the name of the object, by the way. So when I say this dot name, it's referring to the player that I just created. So it's for the current instance. So I'm just gonna hard code this to like let's see. I'm just gonna name it no name, unnamed. The reason I'm naming unnamed is to be like a default constructor. Like if you don't give it a name, I'm just gonna give it a default value here, and then maybe health. Let's say health is equal to. So this health, you can name it. You can do it whatever you want. I'll probably name it 10 here. The reason why I'm going 10 is to visualize like 10 bars. You can imagine maybe these bars have like 10 pixels in them, and each, or not pixels, segments, and maybe each segment represents 1 health. So I'm just gonna stick with 10, which means it's the max health. However you want to think about it. Okay, and then same with the mana here. So let me go ahead and run this real quick. So okay, cool. So it doesn't do anything yet, but there are some variables that are defined, initialized. It might be useful to insert some more functionality here. Like imagine if there was some method that could output these bars here. Right, this is, you can imagine this is like a print function, a print method, where you'll do something like P1, print their statistics, and then it should show like these bars here. So imagine like in the main, right? In the main, you did something like P1 dot display bars. You see what I'm trying to do here? I'm trying to say output this thing here. All right, so let's go ahead and run this, but it doesn't run because display bars does not exist. So let's go ahead and make it exist. All right, so based off how I'm calling it, can folks guess what return type this method is? You can kind of tell it's a void method because we're not storing this function. We're not storing this method into any variables. So you can assume this is a void. It's a public void method. All right, once again, it needs to be public, otherwise the main would have no access to this. So it's a void method. It's called display bars. All right. And you can imagine this method as allowing read access. Right? Allowing read access means to let other parts of the code see what the bars look like. Okay, so let's go ahead and do some output here. The point of this method is just to output the statistics, like I mean not statistics, they're member variables. So I could go ahead and output the name first. Right, system.out.print. Let's see, print. I'll go printf, and then let's just say name. Name is some string, and then it's gonna be this dot name, and then let me just do it for the other stats too. Actually, instead of printing out the stats like this, see, I was planning on printing the stats very boringly, like here, let me finish this over here. So let's go to health over here, and then let's do the mana here. So this is gonna work, but I'm gonna make it look a little nicer. Okay, so let me go ahead and compile this. Save. You have to save both files now. Okay. Cool. So I'm just going to compile and run it. And yeah, we see the display bars right here. These are not actually bars. They're just like plain output. But maybe for the health, maybe you wanted to design like bars instead. I'll probably do like stars to represent each segment. And here, let me line this up a bit. This mana, I'll probably add like 2 spaces here, just to see what happens. Let's put 2 spaces here. Yeah. This way the bars will line up a little nicer. So check this out. Instead of printing out the numbers plainly, like this is a plain number here. Maybe you wanted to print out like a bunch of stars instead. So let me just try that out. And a for loop might be useful for that. You can imagine a for loop that says, for all of the health bars, print a segment. All right, print a segment like this. These bars here. So you can imagine like a for loop that starts at 0, and then it goes all the way to the health. Right, so this is saying for all of the health numbers, right, 0 through 10, print out a star. So let me just go ahead and print out a star. Print out a star, and then maybe at the end I'll print out a blank new line. Print line, yeah, blank new line, just to get ready for the mana over here. Okay, let me go ahead and test this real quick. So Java, and okay, we got a error message, format specifier D. Oh, I messed up over here. There's nothing, I'm not formatting anything into here. That's my bad. Okay, let me remove that D there. Okay, because I'm not putting the number anymore. Okay, there it is. So we printed out the name, which is right here, and then the health, which is all of these bars. Let me go ahead and do the same with the mana. So this is going to be the same thing. Instead of printing the mana bars, I'll do a for loop. That goes through all the mana, and then just does a printf, and then a new line when we finish. Okay, let me go ahead and test this now. So let's go Java. Oh, I need to save this. Save, and then run. Wait, save. There it is. Okay, people see what's happening here now. So we printed out their bars here. All right, let me go ahead and collapse this method so it looks a little cleaner here. Okay, Cool. So let me help folks with a bigger picture here. All we really did right now was design one player. That this is one cookie, but we could create more too, right? Like you could totally do something like player P2, right? P2. This is designing another cookie from the same cookie cutter, and if you were to print it, we should see the same ones. P2.display bars. Let me print out a bunch of equal signs here. Actually, I'll do the equal signs in over here in this method. Basically, so things look a little nicer. Got a bunch of equal signs. Okay, let's test that. Okay, so now if I go ahead and run it. Oh, I need to do a new line right here because the output looks messed up. See right here? I need an additional new line to prefix the equal signs. Okay, so let me go ahead and run it. Okay, so there we are. I just ran the program, and then it constructed 2 players, and then we displayed their bars down here. All right, so we designed 2 of the same players. Sometimes it's necessary to have like a diverse amount of cookies though. Right? These are the same exact cookies, but you can imagine here, we might want to take advantage of like an overloaded constructor. So imagine here, instead of using the default constructor, I used an overloaded constructor, meaning to give some data here, right? Like let's say I put like Andrew here as my name, and then maybe I gave it some custom attributes, right? Custom attributes like what is the starting health and what is the starting mana. Right, so let's say I start off with like 20 health or something, and then maybe I start off with like 5 mana. So people see what I'm trying to do here. I'm trying to invoke an overloaded constructor. All right, an overloaded constructor is a method that takes arguments, and those arguments are used to initialize the member variables. All right, it's just a way of creating custom cookies from the same cookie cutter. All right, so if I were to compile it now, I'm going to get an error message. It says this constructor doesn't exist. All right, so it says there's no constructor that takes 3 arguments, specifically a string, an integer, and an integer. That's what it's saying here. So if we wanted to get this working, we have to make an overloaded constructor. All right, so this is our default one. Let me collapse it. Actually, I won't collapse it yet. Let me go ahead and make another one here. So I want to make a overloaded constructor here. And a constructor is just a method, and the constructor method has the same name as the class itself. So it would just be player here, but with some stuff inside of here. All right, there's no need for a return type, by the way. Like there's no void here. The constructor is one of the only methods that needs no return type. All right, let me go ahead and get the arguments in here. So I need to represent a string, an integer, and an integer. So I'll go ahead and represent that. I'll say string, probably like, I'll call it like initial name. And then these next 2 integers, I'll probably call them the same thing, like initial health, and then initial stamina. All right. So this is an overloaded constructor. Let me do a print statement in here so you can see what's happening. I'll call it like a print line and then say constructing custom player. All right, so let me go ahead and run this real quick. I just want to make sure it compiles. It's not done yet, but it's a good idea to compile right now. Okay, cool. It compiles. And it runs. Let me see the first 2 lines. Cool. So the first one is looking good. This is default. And then next one is constructing a custom player. Looks good. And then yeah, these bars aren't set up correctly yet. You see in the second one, none of these got initialized. All right, which makes sense because our overloaded constructor doesn't really do anything. All right, if anything, we should probably update it now to use these arguments and put those arguments into the member variables. So it's the same as the default constructor, just more custom. So you could say this name is equal to initial name. Right, this is what we were passed. We can say this health is equal to initial health. This dot mana. Okay, let's go ahead and test it now. Cool. So let's go compile and run. And okay, I got an error message here. Let's see. Cannot find symbol. Initial mana. Okay, so I probably spelled something wrong. It's saying I got an error message here. Oh, I meant stamina. Wait, what am I using here? Oh, I'm using health and mana. Okay, that's my bad. I used stamina here. Okay, so I meant mana there. There it is. And then, great. Now it compiles and runs as well. We see that our first one is working. This is the default player. And then for the custom player, that's here, Andrew. And then for some reason, I just gave it some custom attributes. So 20 and 5. Okay, people cool with this so far? Constructing 2 players. Pretty cool, right? So yeah, I would recommend kind of getting creative with it. We should probably implement a couple more methods, and then I'll let folks maybe complete the rest. All right. So let me take a look at this over here. I'm gonna go ahead and collapse some methods so it looks a little cleaner. Let me collapse this default constructor. This overloaded one too. And this display bar, just because we're done with them. Cool. So we got 3 methods, 3 public methods. Maybe we should do some stuff like some methods that can change their member variables. So imagine if there was imagine if P1 took damage for some reason, right? Like let's say P1 takes damage, and maybe it takes I'll say 5 damage actually. I'll take it 5 damage. Or actually let me say I'll say P1 take damage. So this is saying P1, which is right here, right? They start off with 10 health and then they take 5 damage. So it means that we should be able to see their health lower here. So this is invoking a method that doesn't exist yet. See, take damage doesn't exist, but you can imagine this as a button, right? It's a public button that could be used in a game. All right, so you'll get creative with this later, but we'll have to define this method here. This is a, you can kind of tell this is a void method because we're not really storing this value into anything. So you could design this as a public void method. Right, public void take damage, and then it does take an argument. This argument represents how much damage was taken. So I'll call it damage taken here. Damage taken. All right. So what should we do here? The goal of this method is to change their health by subtracting away some number. So you could do something like this dot health is equal to this dot health minus the damage taken. All right, so let me go ahead and run it real quick and see what's happening. So Java game.java, and let's take a look at it. Here, let me simplify this a bit actually. Let's just deal with one player for now. I'm just gonna delete all of these here. Let me deal with player 2 actually. So I'm gonna change these to player 2. So player 2 here, player 2. Okay, just so folks can follow along a little easier. Okay, let's sanity check this. So I constructed a custom player, and I said take 5 damage and display the bars. Does this look about right? Yeah, it looks about right. It looks like 15 bars. Yeah, this looks like 15 bars. 20 minus 5. And if we were to take more damage, like let's say later on P2 take 15 damage for some reason, or let's say 14. Let's just say 14 here. All right. Well, what can you expect if I were to run it now? Let's see. Yeah. Now we see that the health is 1 because 20 minus 5 minus 14 gives us 1 here. All right. So yeah, we got this method working. This method, if you do the reading, you'll see something called mutator. A mutator method. A mutator means that we're changing the member variable. So you could make a mutator method for each of their attributes. Like you could make one that does healing, right? Like the opposite of taking damage is healing. And you could also write some mutators for the mana too, right? Like maybe they use some points in mana, or maybe they drink a potion and this increases or something. All right, so you could get creative with it and do the rest. I'm gonna keep it super basic though, and let folks do whatever they want. All right, people cool with this so far? So we just designed a take damage method. I would consider doing some protection in here. Consider doing some protection. But by protection, I'm talking about like maybe negative numbers. Because it's possible for someone to put like a really large number in here and make your health negative. And that might be, for some folks, you might not want that. For some folks, maybe you do want negative health. So if you wanted to protect it from negative health, you might want to do like some sort of if statement in here. Like if the health becomes negative, then cap it. Like put it to 0. Right? Like if negative, make it 0. So you could do something like that. I'll let you think about it. All right, and maybe some. Maybe we could do another helper method, another mutator method that changes the name. This will kind of help you customize characters along the way. So like imagine later, right? So imagine later on, player 2 wants to change their name. So imagine like player 2 changes the name, and there's a method called set name. Right, set name is like a mutator, like a take damage. And if I were to change my name to like, let me just put my last name here, tack here, right? Let's say I change my name. We can expect that the bars should show something different. It's not going to compile yet because we don't have this set name. So let me go ahead and write this method. Right, this is a void method, so you could design it as a void set name, and then it takes a argument here. It takes a string argument. I'll call it like new name. Right, so if someone wants to change their name, this is considered their new name, and we can use that new name to overwrite it. So now if I go ahead and run it, we see that the name got changed. Right, people cool with this? So we added another functionality. This is useful for just changing member variables. It's this is another mutator method. Right, it allows write access. It allows write access to a member variable. So this is giving public. This is giving public write access to this variable here, but it's doing it in an object-oriented way. So if you wanted to put in some protection, you could. Right, like you could consider doing some more protection. Like maybe if their name is too long, like if their name is too long, or maybe if the name is already taken. I'll let you think about it. If their name is too long, too short, or something. All right. Okay. Cool. So let me just simplify this over here a bit. Let me just delete these mutators. Okay, I'm just gonna simplify this so you can follow along. Let me collapse these methods here. Okay, collapse. Don't worry, I'm gonna upload these to Canvas so you can download them if you can't see these here. Okay, let me go ahead and run this again. I just cleaned up the main a bit. Okay, with these mutators, we can do stuff like change names now. Here, set name. So if we were to have like a default constructor, right? Remember earlier we had a default constructor from P1. So this is invoking the default constructor. All right, and the default constructor shows that P1 is uninitialized, or not uninitialized, they just have no name. So if I were to output this, then we'll see this first player is unnamed, and maybe at some points you wanted to give them a name, like P1 dot set name. All right, this is a mutator method, and you could set it to like, I don't know, let me put like Bob here. When people see what this is saying, it's saying grab the default player and mutate their name to Bob. So now we should see a default player being Bob here. All right, so yeah, all I'm doing here is testing our player methods by using a very simple main. All right, in practice, you might want to do actual logic in this game, like maybe take input from the user, like hey, what do you want your name to be, and then have the user type in the name, and then they press enter. So that's I'm technically hard coding here. In practice, you want to take input probably, like let's say we create 2 players. Here, actually, yeah, here, let's move on. So we're going to move on to something called storing objects into a data structure. And this will help us visualize how to deal with multiple cookies at the same time. And we're also going to use these methods here. But hold up, let me see. I feel like we should add one more method, because all we did were void methods. We should do a non-void one. Let me think. Let me look at this player over here before we do the array list. I want to do a method that's not void. Something that returns something. Let me see what the output looks like. Got the health, mana. I guess we could do something like this take damage method. I'm thinking about making this a Boolean method, because in some games it's possible for the take damage to be ignored, like miss. If you ever played Pokemon, sometimes you'll do an attack and then it misses, so the damage was not taken. So in that case, that would maybe return a Boolean, like whether or not the damage was successful. Let me think real quick. Yeah, I guess we could make this a Boolean. Let's do that real quick. Like, so I'm making this a Boolean method just to have some more learning here. But sometimes maybe you want to have some random number generation where it's possible for a player to not take damage. Like let's say there's a 50-50 chance of this not happening. So we could code in a 50-50 chance, right? We could say like, if something, then they take damage and return true. All right, else we could return false. All right, so people see what I'm trying to do here. I'm trying to code in a chance, right? Like if the chance happened, they successfully took damage. Right? And if this didn't happen, it means they unsuccessfully took damage. So you could do some random number generation here, like a 50-50 chance. And one way you could do a 50-50 chance is by generating a random number. Like, I forgot how to generate a random number. Let me see. Let me go on my JShow real quick. I gotta pull up my old slides, but I think from memory you could do like random equals RNG. So this is like constructing a random object. And then we could say RNG.nextInt, maybe between 0 and 1. Yeah, we could do something like this. So you might remember that this is a method that returns a random integer from 0 to 2, but 2 is not included. So it's either 0 or 1. So we could generate a random number and check if it's 0. Right, that's kind of like a 50-50 chance. So this is kind of a 50-50 chance. Yeah. So let me go and do that. Let me say random RNG is equal to new random, and then say something like if RNG.nextInt is equal to 0. Right, so this is a 50-50 chance that I'm coding in. 50-50 chance. That's what I'm coding. If this number is 0, then they take damage and return true. So let me go ahead and compile this. And oh, okay, I forgot to import something. So since we're using random outside of the main, we gotta import something. I think it's import. Let me look up where this comes from. This random class comes from some library. Random class in Java. So it comes from java.util.random. Okay, so let me go ahead and include that. Import. Cool, now we have access to this class, and this should no longer have an error. Okay, cool, so it compiles. It doesn't do anything yet because we never took advantage of this method, but let's go ahead and use it. Let's say, let me simplify this again. I'm just gonna get rid of P1 here. Let's only look at P2. Okay, so let's say at some point P2 takes damage. But this is now a Boolean function, Boolean method. So let me put in like 10 here. Let me put in like 19 actually. So I'm trying to take all the damage but 1 here. But this is now a Boolean function method. I mean, even though we're not storing the value into anything, like you know how we're not storing the value into something, right? It's still like a Boolean method because this is doing something and evaluating to like true or false. So this does evaluate to like true or false, but it does that after this computation here. So let me go ahead and run this real quick and see what happens. And check it out. So I just ran it, and P2 successfully takes damage, right? Because 19. and now they have 1 health. But if I run it again, now they have full health, because there's a 50-50 chance. Right, so in this case, this didn't happen, so it stayed the same. This is 20 over here. All right, let me keep running it. And yeah, stays the same. Let me run it again. Stays the same. It is a 50-50. This time it's less. So if you wanted to, you could capture this variable into something. Right? This method does return a variable, a boolean. And if you wanted to capture it, you could say like you could call it like attack success or something. Right, so this is a variable that represents whether or not this method successfully did it. Right, so if you were to capture that variable, you could do some additional output, like if attack success equals false, right? Then this means they missed. So you could do something like print line attack missed. Right, and then maybe else attack succeeded. Print attack succeeded. Right, so let me go ahead and run this Java game, and then yeah, see it says attack missed, and then run it again. And attack succeeded this time, so we got this. And, yeah. So this was just an example of a method that can return a value, because sometimes you need information from the player, right? And one of the only ways to get information from the player is by having the method return something. All right, let me see what else we should do to this. I'm planning on going into data structures for storing players. Let me think of one more thing though. Set name, take damage. Okay, I'll probably do another example on Thursday, just with some more methods. Okay, we should move on though. So this was an example of designing a player class. It's very simple right now, but with this cookie cutter, we're able to spawn multiple cookies. In some RPG games, like a multiplayer ones, you'll have like a bunch of players, right? Like player 1, player 2, player 3, and maybe they're all interacting with each other by taking turns or something. So if you wanted to spawn multiple players, it might be necessary to store them into a data structure. All right, I'm not going to use a deck of cards here, but imagine we declared like an array list, some sort of data structure that stores all of the player information. Okay, so one way we could do that is by declaring an array list, I mean. So check it out. This is where it's going to look a little weird. So imagine if I create an array list, but the array list contains players. All right, so this is the type. All right, so we got an array list of players, and you can call it whatever you want. I'll probably call it like team. I'll call it team, because it is a data structure, and a bunch of players can be a team. So let me set this to a new array list of players, and then I'll call it like I'll just leave it like this actually. So it's size 0 right now. Let me run this. See where it runs. Okay, it runs. It doesn't do anything. But let's say we wanted like 3 players for some reason. Right? Imagine if we had some variable that represents how many players, like num players. Let's say there's 3 for some reason, and maybe we wanted to create 3 players, 3 default players, and push them into this array list. So you can imagine like a for loop that says insert a player into this team. All right, 3 times. All right, so this is saying do something 3 times. And in particular, maybe we want to push back a player. So let me go ahead and create a player. All right, so this is well, actually, you could push back right away. So you could, I mean, not push back, add. So I'm using this method here, array list Java. I'm planning on using this method here called add, and which adds an element into the array list. So I could say team.add a player. Right, the player is here. So we could construct a default player by doing this right here. All right, so this is constructing a new player and adding it to the team. So let me go ahead and run this real quick just to see if it works. And okay, cool. So constructing default player, and it does it 3 times. So there's 3 default players. I should probably sanity check it real quick. So let's say I did like a separate loop that just sanity checks and prints it all out. All right, so you can actually do it in the same loop, but I'm gonna do it in another loop just to be more modular. And let's say I did, let's say I wanted to display their bars. All right, so the bars, this is a player, it's a player method. So we have to access the player. Right? And one way we can do that is by using this array list method called get. Right? Get takes a number which returns an element. So if we use like team.get I, right, this represents a player. And that player has display bars. So you can say dot display bars here. And let me go ahead and test this here. All right, so I know this looks trippy, but this is like a player. This is like P1 display bars, and then it goes to P2 dot get display bars. So we can go ahead and test that. And yeah, so we constructed 3 default players, and now we're printing them out. All right, so those are sanity checks. In practice, you might want to have some functionality to change these names. Like if these are all 3 actual players, you might want to say, hey, what name do you want it to be? So if you wanted to, you could do it in this for loop here. Right? Either of them work. You could do it here, like say player something. What name do you want? So let me go here and put in like a player something. Player something. What name do you want? What name? What's your name? And then let me put a number here. Okay. So here, let me run this so you see what I'm trying to do. Let me run this over here. Actually, I need to put a new line here, but I'm gonna remove it just to make things look nice. Okay. So check this out. So this is just a print statement. It doesn't do anything yet, but you see it says constructing default player, and it says player 0, what's your name? We're trying to give player 0 a chance to type something here, right? And then same with player 1 and number 2. So it might be useful to take input here, and I'm gonna take input as a scanner. So I might want to set up a scanner object. Let me set up a scanner here. I'll call it like user input. And I'm going to take it from system in. This is the standard input. So this is like the keyboard. All right, so num players. And then let me, here, when we prompt, we could do like, we could go user input dot next int. Oh no, not next int, just the next line actually. The reason I'm using next line is just because of this method here. So this is a scanner method. You've seen this method before. Next line. All right, which pretty much lets you type in a bunch of characters and spaces, and then when they press enter, that whole thing is considered a string. So we could say grab that whole string and then maybe store it. All right, I'll probably store it into like a variable. I'll call it like custom name. All right, and then using that custom name, we could mutate their attribute. Right, we did make a method here called set name. So we could do like team at I, and then set the name to a custom name. And people see what's happening here. Let me just put in some new lines here. So this is saying construct a object and then prompt the user for their name, and then grab the scanner and then put the scanner input into here. So let me go and test this real quick. Okay, cool. So it says player 0, what's your name? So we're stuck right here. We're waiting for a new line, right, for player 0. So I'll type in like Andrew, and then the second I press enter, it's gonna do this. It's gonna mutate their name. So press enter, and then boom, it's done. And then now it's constructing another player, right? This is a construction, so it printed out constructing default player from here. All right, constructing default player. And then now we're waiting for another one. Let me put like Charlie here. Enter. And then now player 2, what's your name? So let me go Bob. And then I'll press enter, and then everything should be done. So there it is. I press enter, and it's all done because this loop only happens 3 times. And then now we do another for loop that prints out the bars, which we see here. People cool with this so far? Okay, let me check the chat. Are there any questions, folks? I'm gonna give it a minute. Okay, cool. Yeah, quite a lot to take away from this example. So yeah, this, I would recommend getting creative with it. You can probably create like a fully fledged terminal-based game by now, like some sort of maybe turn-based thing. Maybe if you ever heard of like Pokemon. I never really played Pokemon, but I know on the Game Boy it was like a turn-based game. Like over here, not the Game Boy, the Game Boy Advance. Yeah, so if you ever played these, the gameplay looks like they're kind of turn-based. So you see, like here, this is a random picture. We have like, if you can see it, there's like a team here. The team has different statistics. They have like a name, they have like a health, and they have like some other statistics too. So you could probably create some sort of turn-based Pokemon game now. Okay, let me see if we covered everything. Cool. So we just create a player class and we stored object into a data structure. I'm planning on doing another example later, like maybe with a deck of cards. That this would probably be more suitable for next week. But yeah, that's the player class. Okay, I should probably. Yeah, I think we should be good from here. Let me study this player thing real quick. I'm not happy with this player class because it's not diverse enough. It doesn't have a diverse amount of methods. Yeah, I'll just leave it as this, actually. I'll let folks get creative with it. But basically, I'm saying I'm not happy with it because the player class is too simple. And for a more fully fledged game, you might want to have some more methods. So you can think about it like a heal, right? You can imagine a method that does the opposite of this, and methods that change all of these over here somehow. Okay. Let me upload this to the canvas in case people need to download it. I'll do that after this recording. Okay, so that's about it for this player class. Let me yeah, highly recommend playing around with it yourself. Let's see. Okay, well that was a pretty short day today. The whole goal of today is just to do another example of a class. Let me give a sneak peek into later. On Thursday, we're gonna cover something called inheritance. Wednesday. Inheritance is object-oriented programming again, but it's fancier. We won't get too into depth on this, but basically inheritance means you can create classes that inherit functionality from other classes. All right, so this is kind of like if you were to take a look at the readings a bit, you don't have to fully understand this chapter. It is a little harder to read. In the 9.1, this is a little more advanced. But if you wanted to take a look at what inheritance means, this pretty much means that you can create classes from other classes. And if you scroll down a bit, they use a example called a counter here. So let me see over here. Let me see, where is it at? There's something called counter here. Where's a counter? Let me just search this whole page. I think I skipped over it. Counter. Oh, okay. I'll visit this on Thursday. But we did do this last week, like a simple class that represents a small integer. But sometimes you want to design methods that, classes that inherit from a parent. So imagine this is like a parent class, and you wanted to create a child class. So this child class is called supercounter. And when I say child, I'm saying that they inherit from the parent. So on Thursday, we'll learn about something called extends. Right? Extends means we're inheriting these methods into this supercounter here. All right, so it's very similar. The only difference is you're able to override methods. So if you wanted to create like a supercounter that increments by 5, this is like overriding. It's saying take the old method, but say it does this instead. All right, and yeah, and you'll see an example down here. They're kind of invoking the child here, and then this is a parent. They're invoking the parent, and then they're invoking the child, and then kind of showing the differences between their functionality. So you could take a look at this. This section is a little harder to read, but I'll do my best to simplify it down on Thursday. All right, this is going to help us a lot for the future. Let me look at the schedule real quick, because we need to do something called visual programming, which is for like designing like graphical user interfaces and some more fun stuff, you could say. So just to kind of show you where we're at. We are right here. We're on week 13. We pretty much covered classes. I'd recommend doing a bunch of practice on this, like maybe some more readings on it, and hobby projects. Wednesday we'll talk about inheritance, which will help us with visual programming, by the way. So visual programming, you're probably getting tired of the terminal right now, right? Like kind of seeing all of the output here. You're probably getting tired of like typing things, and maybe you want to start dealing with graphics. So I did some I'm gonna look into JavaFX for Wednesday. This is a library. There's a bunch of libraries you can do, by the way. This is just one of the arguably easier ones to read. So you could let me pull up these examples here. Actually, let me just look up like a Pong game. You could look at people's examples. Like you could look at Pong here. This is like an old game, and there's probably gonna be yeah, there's a bunch of YouTube videos of people saying, how do you design Pong using this library? So you could. So here's one that's written by a random person. Let me take a look at it. 7 years ago. And yeah, so this is a Java game, 100% Java, and it's written using some library. Let me just take a look at the source code over here. Source, and then let me look at the Java, main.java. This is the entry point, probably. Let's see. Okay, cool. Check it out. Check it out. So it looks like the programmer here created a class called main, but it inherits from something called application. So this application is the library, by the way. There's a library called JavaFX, which provides classes to do graphics, and it uses inheritance, so it makes it easier for you to set up graphics. Like see here, all you have to do is say .show. And .show is already provided by this application. So by doing .show, you're able to make things a little easier. All right, so let me pull up the primary documentation, JavaFX. If you want to get a head start into this, you could look at some tutorials. Like let me see. There's some easy tutorial somewhere. Let me look it up. Getting started? I think I clicked on this one already. This one? JavaFX. Okay, I'm trying to find this certain tutorial that was... Is it this one? Hold on, give me 1 minute, folks. I'm gonna dive through some documentation real quick. Getting started. Hello world. I don't want to use Maven. Let me back up a bit over here. API documentation. I found it earlier in the beginning of class. Is it this one? No, it's not this one. Let me back up a bit. Where is it at? This one over here? I think I already clicked this. Yeah, okay, I'll find this again later. I gotta search again. But yeah, this is just a sneak peek into the future. There's a bunch of other libraries too. There's some fun ones. Like if you look into processing. Let me see if this still exists. Yeah, so earlier some people used to teach Java using a software called processing, which is a way of making Java do a bunch of graphical stuff here. So we'll see this stuff later. Like here's some examples. Let me pull up like a nice example here. Some nice graphics. Let's see, what's a good one here? Let's see. I guess this is a small one over here. Let me click on the first ones. Perspective. Yeah, so this looks like a program where you can kind of rotate the mouse. You can move the mouse, and then it'll kind of show you different different pieces, perspective. But this is pretty much written in like object-oriented Java. This is a different style, but that's kind of what object-oriented programming makes us do. It makes things a lot easier to read, and by kind of encapsulating methods away. So yeah, we'll see something like this next week. Okay, so that's about it for now, folks. I'm gonna let folks get creative with it, and yeah, let me know how it goes, folks, with the object-oriented stuff. This is quite a dense topic. Okay, let's end it here, folks, and I'll see you all again on Wednesday. See ya.